So a predicate is a statement that contains variables that may be true or false depending on the values of these variables. It is represented by letter P. The notation P at X is used to represent some property or predicate that X may have. So yung domain of a predicate variables, collection of all possible values that the variable may take. So for example, yung X, uh, pwedeng whole numbers, pwedeng all integers that is divisible by 3 and 2. So yung may mga ganon na yun lang ang pwede mong i-replace sa variable na X. So consider the statement X is greater than 3. This statement has two parts. The variable, so yun yung X. The first part and the second part is the predicate is greater than 3. Sige, i-record ko lang para okay, so a predicate is a statement that contains variables that may be true or false depending on the values of these variables. So, inulit ko lang, represented by letter P. The notation P at X is used to represent some property or predicate that X may have. The domain of predicate variable is the collection of all possible values that the variable may take. So, sabi nga kanina, pwedeng all whole numbers or whole numbers that is divisible by these numbers o may mga certain condition na yun lang ang pwede mong i-replace dito sa variable na X. So consider the statement X is greater than 3. This statement has two parts. The variable, which is the X, and the number 2 is the predicate, which is greater than 3. So the statement X is greater than 3 can be denoted by P at X. So the statement P at X is said to be the value of propositional P at X. So once the value has been assigned to the variable X, the statement P at X becomes a proposition and has a truth value. So yung X, kapag pinalitan na natin yan ng domain or mga possible values na pwede niyang magamit, so saka na siya magkakaroon ng truth value. So example, let P at X denote the statement X greater than 3. So what are the truth values of P2 and P at 4? So dito, supposed to be X ito, yung 2 and 4. Pinalitan na natin yung variable ng value. Okay, so ngayon, proposition na siya. Kasi hindi na variable lang nakalagay sa kanya. So, dun sa application natin, yung statement na X greater than 3, yung variable na X, papalitan natin nung domain of values na 2 na ni-replace natin kay X. So, 2 greater than 3, false. Alam naman natin na 2 is less than 3. So, hindi siya mas mataas kay 3. So, false. So, then, yung second example is P at 4. So, P4, so, we replace the variable X of the statement na X greater than 3. 4 greater than 3, which is true. Okay, so ganun yung ginagawa natin kay predicates. So another example, so hindi lang isa, pwedeng dalawa or tatlong variable. So let P, X, and Y denote this statement. X is equal to Y plus 3. So gumamit tayo ng dalawang variable dun sa statement natin. Then what are the truth values of the proposition P75, 84, and 63? So yung the first value is for the variable X. Then the second value is for the variable Y. So now, we replace the variable X and Y. So naging proposition na siya. P75, P84, P63. So, 7. So, nireplace natin yung X ng 7 is equal to 5 plus 3. So, yung Y, pinalitan natin ng 5. Ito yun. So, 7, then 5. So, kapag pinrocess natin yan, 7 is equal to 5 plus 3, 8. So, 7 is equal to 8 is false. Kasi hindi sila equal. Then, yung pangalawa is 8, 4. So, 8 for the variable X and 4 for the variable Y. So, 8 is equal to 7. So, false pa din dahil hindi sila equal. Then, P at 6 and 3. So, 6 is equal to 3 plus 3. So, 6 is equal to 6. So, which is true. So, true siya kasi equal yung 6 at saka 6. Nakuha ba? Nasundan?
Opo.
Opo, sir.
Opo, sir.
Okay,
Yes po,
so
sir.
another example is let P at X denote this statement. Computer X, so X is our variable, is under attack by the intruder. Suppose that of the computer on campus only CS103 and PR003 are currently attacked by the intruder. So given na ito lang dalawa yung currently attacked by the intruder. So what are the truth values of P? So yung domino values natin, so ni-replace natin. So proposition na siya dahil ni-replace natin yung variable X. So application is computer CS103 is under attack by the intruder, which is true. Kasi given na CS103 is currently attacked by the intruders. Then P CS101 computer CS101 is under attack by the intruder. So hindi siya given dun sa domain natin na ang stated lang dito is CS103 and PR003. So kaya siya naging false. Then PR003, computer PR003 is under attack by the intruder, which is true. Kasi given, kasama siya doon sa given. Isa siya sa domino values na pwedeng maging value ni X. So the predicates in general, a statement involving the n variables. So x1, x2, xn, x to the n o xn can be denoted by so p, then yung mga variable natin. X to the n, ibig sabihin yan, yung kung hanggang gaano karami. A statement of the form px1, x2, x3, x2n is the value of the propositional function p. So, propositional function P at the n tuple x1, x2, x3, np, also called nth place predicate, so other term na pwede natin gamitin, or n-nary predicate. So kapag multiple variables yung gagamitin natin kay function P. Okay, so meron tayo ditong example. So let Px denote this statement: x is a natural number divisible by 5. Okay, so ito yung variable natin. Ito yung predicate. So sa predicate natin, ang sabi, ang value ng x ay natural number na divisible by 5 lang. Okay, so pin-provide natin yung mga value 10, 25, 31, 100, and 126. So lahat yan proposition. So yung P10, so yung 10 is a natural number and also divisible by 5. So this is true. 25 is also a natural number and divisible by 5. So true ulit. Yung 17 ay natural number pero hindi siya divisible by 5. So this is false. 31, natural number and not divisible by 5. So this is false. 100, natural number and divisible by 5. True. Then 126 is also a natural number but not divisible by 5. So ito ay false. So nakuha? Nasundan?
Opo, sir.
Opo.
Okay. Sige, yung second example, yung nasa baba, sagot sa chat box. So paki-type sa chat box yung pagkakasunod-sunod ng truth values ng mga proposition natin na P5, 10, 20, 30, and 100. Doon lang sa chat box natin ng Google Meet. Okay, so try na natin sagutan. Okay, so let Px denote this statement: x is a natural number smaller than 30 and divisible by 10. So 5 is smaller than 30, pero hindi naman siya divisible by 10. So meron tayo ditong n. So ibig sabihin kailangan smaller than 30 siya and divisible by 5. So ito ay false. X is natural number. So 10 is natural number, true. And divisible by 10, so ito ay true. Natural number that is smaller than 30, yung 20, true. And divisible by 10, so ibig sabihin ito ay true. Tapos yung 30, so hindi naman siya smaller than 30 pero divisible by 10. So ibig sabihin nito false. Kasi hindi siya smaller than 30, equal sila. Then ito ay natural number, so hindi smaller than 30. Kasi 100 siya, pero divisible by 10, so false pa rin. So yung ano natin dito, titingnan natin kung ano yung, di ba kapag end, ang ginamit natin, kailangan maging true yung both expression natin na natural number smaller than 30 and divisible by 10. Kung or yung ginamit natin, ibig sabihin, basta smaller than 30 or divisible by 10, true na agad siya. Okay, so mukhang medyo nalito kayo doon. So, question. Question, nakuha na, naintindihan na kasi parang pare-parehas kayo ng sagot doon sa chat box. Kung merong question, magtanong na para habang another example. Mag-create lang ako ng another ano. So x is an integer number. So odd numbers and divisible by 3. Okay, so for example, x is an integer number that is odd number and divisible by 3. So hindi ibig sabihin na kapag nakita natin na odd number, i-assume na natin na true kasi odd number. Meron pa tayong another criteria dito na divisible by 3. So for example, ito yung domain niya, so 3, 7, 11, 15, 19, okay. So let's say okay, so anong pagkakasunod-sunod nung answer natin dito or nung truth values? Sige, pakiano nga sa chat box, tingnan natin if nasundan nyo yung sa previous example.
Kulang 15, sir.
habol na lang natin 15. Singit na lang natin dito. Yan, 15.
3, 6, 9, 12, 15.
Okay, so sige, subukan na natin. So 3 is odd number and yung 3 ba divisible by 3? Yes. So this is true. So 7 is also odd number and divisible ba siya by 3? Hindi. So ibig sabihin ito ay false. 11 is also odd number and not divisible, hindi naman siya divisible by 3. So ito ay false. Yung 15 odd number din pero divisible by 3. So true. Yung 19 is odd number, hindi siya divisible by 3. So this is false. Yung 33 is odd number and divisible by 3. So ito ay true. So ang pagkakasunod-sunod natin ay true, false, false, true, false, true. So true, false, false, true, false, true. So okay na, maliwanag na. Nakuha na. Nasundan na?
Opo.
So wala nang question dito. Wala nang tanong sa predicates.
Okay na po, sir.
Okay na? Okay, so proceed tayo sa quantifier. So as its name suggests, quantifier is an operator that states that a predicate is true for a given quantity of objects. So, meron ditong description ng quantifiers. So, meron tayong universal at saka existential. So, yung universal, Px is true for every x. So, ibig sabihin nito, yung P at x natin, yung truth value niya, dapat true for every value of x. So, magiging true siya for every x. Kailan siya magiging false? There is an x for which P at x is false. So, there is. Ibig sabihin, kahit na mayroong isa or dalawa o tatlo, kahit sabihin natin 10 yung domino values natin, isa lang yung nag-false, so automatic, false na yung truth value niya. Dito naman, para maging true, kailangan lahat ng lahat do sa domino values ng variable natin maging true. Sa existential naman, kailan siya magiging true? There is an x for which Px is true. So there is isa. May isang maging true na yung truth value natin. Kailan siya magiging false? P at x is false for every x. Magiging false siya kapag lahat ng value doon sa domain natin magiging false. So dito, ang ginagamit natin dito is yung conjunction. Dito ay disjunction. Sa conjunction, magiging true lang siya kapag true lahat. Kapag may naging isang false, false. Sa disjunction, kapag may isang true na yung truth value ng statement natin o nung proposition natin, yung false naman, kailangan maging false lahat. So the universal quantification of P at x is the statement P at x for all values of x in the domain. So domain, ito yung list natin na possible values na maging value ng variable natin. So the notation universal quantification of P at X. So ito yan, universal quantification of P at X. So the inverted A is called the universal quantifier. So we read the universal quantification of P at X as for all X of P at X, or for every X of P at X, and then an element for which yung element na magiging false dun sa P at X natin is called a counter example of universal quantification of P at X. So, example. So, example 1, let P at X be the statement X plus 1 greater than X. So, ito yung statement natin. What is the truth value of the quantification of P at X where the domain consists of all real numbers? So, consists of all real numbers. So, siyempre, subukan nating i-analyze din yung statement or obserbahan natin kung ang hinahanap kasi natin dito is yung truth value ng statement. So, base dito sa explanation na to, because P at X is true for all real numbers X, the quantification of P at X is true. Look for table 1. So, paano yun? So, for example, let's say, real numbers. So, start tayo ng 1. So, i-replace natin yung statement, yung variable ng statement. So, X plus the value ng X, ipa-plus natin ng 1 greater than 1 is equal to 2 greater than 1. So, ito ay true. So, try natin ngayon yung 2. So, 2 plus 1 greater than 2. Okay, so true pa din. So, mapapansin nyo, for every value na i-compare natin, nag-a-add tayo ng plus 1. So, yung nasa left side natin, palaging mataas ng isa dun sa right side kasi yung value ng X yung ginagamit natin. So, kung kahit na billions of numbers pa yung marating natin sa comparison, ang palaging lalabas ay true kasi palagi siyang mataas ng isang number dahil nag-a-add tayo ng 1 dun sa value ng X tapos i-compare natin dun sa previous value ng X. So, wala tayong value ng X na magpo-false. Di ba? So, kaya sabi dito, P at X is true for all real number X. So, the quantification of P at X natin is true based on the table 1 na kailan siya magiging true? P at X is true for every value of X. Okay, so yun yung first example. So mag-proceed tayo sa second example natin. Okay, so let P at X be the statement X greater than 2. So what is the truth value of the quantification of P at X where the domain consists of real numbers. So, Px is not true for every real numbers x. So, bakit? So, for example, subukan natin muna ng 1. So, 1 greater than 2. False agad siya. False agad kasi hindi naman mas mataas si 1 and 2. And then, based doon sa description doon sa table natin, kailan siya magiging false? There is an x for which Px is false. Ibig sabihin, yung truth value natin, meron ng isang nag-false o yung universal quantification natin, meron na nag-false dun sa value ng x. So, yung truth value natin, automatically false na. Siyempre, kahit pa, let's say, 3 and above, 3 and billion na numbers, magiging true na siya. Magiging true. So, mamaya assume natin, true lahat pagdating sa 3. So, true yung truth value. But then, hindi mo kinonsider yung value na 1 at saka 2 na pwedeng maging false, magkakamali ka ron. Kasi, eto false, so ibig sabihin, magiging false, not true for every real number. So, for instance, P is 1 is false, then that is x is equal to 1 is a counterexample. So, for the statement, quantification of P at x. Thus, sa quantification of P at x is false. Kasi meron ng isang nag-false. Nakuha? Nakuha nyo? Nasundan?
Opo.
Yes po.
Po, sir.
Okay, so when all the elements in the domain can be listed, say x1, x2, and xn, it follows that the universal quantification P at x is the same as conjunction. Yung sinabi ko kanina na conjunction. So yung lahat ng proposition natin, gagamitan natin once na ni-replace natin si x ng value. So, i-perform natin yung conjunction. Siyempre, kapag may isang nag-false dyan, automatic false na yan. Magiging true lang yan kapag true lahat. So, because this conjunction is true if and only if the conjunction of P, X, 3N are all true. So, malinaw tayo dun ha. Ang ginagamit natin dito is conjunction. Example 3. What is the truth value of quantification of P at X? Where P at X is the statement X squared less than 10. And the domain consists, so ito yung domain natin, consists of the positive integers not exceeding 4. So, identify muna natin yung mga positive number na not exceeding 4. So, 1, 2, 3, 4. So, positive number not exceeding 4. So, yung apat na yan. So, ito na yun. The statement quantification of P at X is the same as the conjunction of P1, P2, P3, and P4. Okay, so, ngayon, yan na natin na, okay, so, P1, so 1 squared less than 10. So 1 squared is 1 less than 10, true. So P 2, so 2 squared is equal to 4 less than 10, true pa din. P 3. So 3 squared less than 10. So true pa din kasi 3 squared is 9, less than 10, true. So yung 4 na tayo, P 4. So 4 squared greater 4 squared less than 10 is equal to false. Kasi 4 squared is equal to 16. And 16 is not less than 10. So ito ay false. So conjunction ng true, 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 false, yung truth value natin is false. Because the domain consists of integers 1, 2, 3, and 4, because the PF4, which is the statement 4 squared less than 10, is false. It follows that the quantification of P of x is false. Okay, question. Question. Question, violent reaction, clarification. O baka meron kayong
Wala
tanong?
po, sir.
Wala po.
Okay, so wala kayong tanong. Mhm. Okay, so maliwanag tayo dun sa universal. Okay, so di ko pa pala napalitan nito. So the existential, yan, quantification of P of x is the proposition there exists an element x in the domain such that P at x. So there exists, ibig sabihin, merong true. We use the notation, the inverted EX, so at P at x for all the existential quantification of P at x. So E is called the existential quantifier. A domain must always be specified when statement the existential quantification of P at x is used. So the meaning of quantification of or existential quantification of P at x changes when the domain changes. So kanina nga, di ba? So nakita natin na pag pinalitan natin yung variable, yung truth value na natin nag-iiba. Without specifying the domain, the statement of existential quantification of P at x has no meaning. The words there exist, we can also express existential quantification in many other ways, such as by using the words for some, for at least one, or there is. So the existential quantification of P at x is read as there is an x such that P at x, or there is at least one x such that P at x, or for some x of P at x. Example, let P at x be a statement x greater than 3. So what is the truth value of the quantification of P at x where the domain consists of real numbers? Because x is greater than 3 is sometimes true. For instance, when x is equal to 4, P at x, the existential quantification of P at x is true. So, balikan nyo doon sa table 1, makikita natin na kailan siya magiging true, there is an x for which Px is true. So, tingnan natin kung, di ba, x the 3. Okay, so, P, so let's start with 1. So, 1 greater than 3. False. So, P2, 2 greater than 3. False. So, 3, so 3 greater than 3. So, 3 is not greater than 3. So, false pa rin kasi equal sila. So, false pa rin. So, 4, so 4 greater than 3. So, ito ay true. So, there is true. So, there is true for P at X. So, ibig sabihin yan, true yung truth value natin. So, para dito sa statement natin, true yung truth value natin. So, another example is, let P at X be the statement X is equal to X plus 1. What is the truth value of the quantification of P at X where the domain consists of real numbers? Because P at X is false for every real number X. The existential quantification of P at X, which is P at X or P at X, is false. So, false nga ba siya lahat? So, subukan muna natin yung 1. So, for every real numbers, okay, so, for example, x is equal to, so yung 1 x natin, then x, then plus 1. Sila pa. So, is equal to false. Kasi pag in-add mo na yung 1 dyan, 1 is equal to 2, false na. Ngayon, kapag nasa 2 ka naman ngayon, so 2 is equal to 2 plus 1. So, is equal to false. So, every value for x, compare natin, then magpa-plus tayo ng 1 dun sa value ng x, magpo-false siya. So, for every value of x, false, which means yung quantification of P of x natin is false. Kasi lahat ay naging false. Okay, question. Question. Question dito. Violent reaction. Clarification. Walang tanong?
Wala po.
Ha? So, when all the elements in the domain can be listed, say x1, x2, xn, it follows that the existential quantification is the same as disjunction. Pinalitan ko na to bakit ito na naman? So, disjunction to, because this disjunction is true if and only if at least one of P at X to the N is true. So, kapag ka naging true. Okay, dito naman, what is the truth value of the existential quantification of P at X where P at X, this statement X squared greater than 10. And the universe of discourse or the domain consists of positive integers not exceeding 4. So because the domain is 1, 2, 3, 4, so the proposition quantification of P at X is the same as disjunction. So or yung ginagamit natin dito kapag merong isang true, yung buong statement natin is equal to true. Based dun sa statement natin, if we replace the value of X of the domain 1, 2, 3, and 4, merong isang magto-true dun sa 4. 4 squared is equal to 16. So ito ay false. Ito ay false. Ito ay false. Then ito ay true. So is equal to true. Because P4 is, which is the statement 4 squared greater than 10 is true, it follows that quantification of P at X is true. Question. Clarification. Walang tanong?
Wala po.
Okay, so sige, subukan niya natin na saglit wait lang ako yung mag stop sharing lang. Wait lang ko lang na example ng pwede nating paganuan. Okay, so ayan yung ano natin. Sample problem. What is the truth value of universal quantification of P at X for the domain of values consists of integer numbers not exceeding 10 and even numbers? So, yung truth value, pakisulat yung answer. So, ano yung truth value natin dito? False. Sige, tingnan natin sa... Okay, so for example is yung where the domain of values consists of integers numbers not exceeding 10 and even numbers. So wala tayong pin-provide na tawag doon, specific value dun sa domain na inilagay natin dito. Pero makikita natin, kung intindi natin ito mabuti, numbers not exceeding 10 and even numbers. So ano ba yung mga numbers na not exceeding 10 and even numbers? 0, 2, 4, 6, 8, 10. Diba? Based kasi dun sa unang example natin, ang given lang natin ay saglit yun ako lang. Gaya nito, where domain consists of real numbers, ibig sabihin, yung domain natin naka-range lang sa real numbers. Yung second naman na domain natin, the universe of discourse consists of positive integers not exceeding 4. Nag-provide na agad tayo ng restriction kung ano lang yung pwede natin gamitin. So, 1, 2, 3, 4. So, dito, ibinigay na agad natin yung restriction na integers number not exceeding 10. So, not exceeding 10, ito. And even number. So, ibig sabihin, ito na yon. So, kapag replace na natin yan sa value ng P, yung 0, automatic true kasi integers number not exceeding 10, so wala yung 0 kasi wala namang ano yun. So 2. Integers number not exceeding 10 and even numbers, so even numbers 2. Ito ay true. Yung 4, true. 6 is true. 8 is true. 10 is true. Bakit hindi natin ginamit si 7 or si 5? Hindi siya kasama dun sa domain of values na integers number not exceeding 10 and even number. So, ito ay true kasi lahat sila ay true. Pero kapag tinanggal ko to, yan, diyan na papasok, sasama si 1, 2, 3, 1, 3, 5, 7, 9. Doon na siya magiging false. Okay, so question. Question sa example na to. Kasi di ba ini-specify na ano yung ah, composition ng domain natin. Ito na yon, ito na yung value natin. Integers number not exceeding 10 and even numbers. So question dito, false, false. So mukhang ang kailangan lang is mag-focus kayo doon sa domain of values. Question. Question dito. Walang question. Nakuha ba? Another example. Okay, so existential tayo. Okay, so for example, so kung i-ano natin yung domain yan, P hanggang 20 o P hanggang 19. So, P1, ano na lang natin. Para mas konti. So, less than 7, divisible by 3, and 5. So, P1, P2, pa-specify yung truth value ng mga proposition natin, then yung truth value ng statement natin. Ano na? Iglalagay lang ako ng statement na Dito meron tayong statement na X yan. So, meron tayong statement na X greater than equal to 3. Saglit ah. Dalawa lang to. Tanggalin ko lang to. Ayusin ko lang saglit ah. Yung muna kanina, ayan. So what is the truth value of existential quantification P at X? First statement. So yung statement natin, nag-provide tayo ng statement. X greater than equal to 3 where the dominant values of numbers less than 15 divisible by 2 and 4. Okay, so ano yung possible value natin na pwedeng gamitin? Sige, ano yung pakitype na lang sa chat box? Na pwede nating i-replace kay X. 4, 8, 12. Okay, very good. 4, 8, 12. Kasi si 4 divisible by 2 and 4. Si 8 divisible by 2 and 4. 12 divisible by 8, 2 and 4. So ano ngayon yung truth value ng statement natin? Using those values 4, 8, and 12. True. Okay, so So P 4, so divisible by 2 and 4. So X 4 is greater than 3 is equal to true. P 8 is equal to 8 greater than 3 is equal to true. So P 12 greater than equal to 3.
Tingnan mo.
So is equal to true. So sa existential, kapag merong isang true, yung expression natin na x or statement natin na x greater than equal to 3 is equal to
Tingnan mo yung ginagawa ko, pre.
true. Okay? So, isang example pa bago tayo mag-end.
Tingnan mo to. Hindi. Makikita to. Hindi pa nga tapos, oh.
Up to 9 sharing lang ha.
Wait lang.
Nag-lag pa. Nag-lag pa. Okay, so find the truth value of universal quantification P at x where statement x plus x greater than x squared where the domain of values consists of integers less than 20 divisible by 2. So, paki-type na lang sa chat box yung uh, truth value for every P at X and then yung truth value nung statement natin. Naglalag kasi kaya medyo mabagal. Values natin for X o yung domain of values natin. So, less than 20 divisible by 2. So, ibig sabihin, lahat ng even numbers na less than 20, 2, 4, 6, 8, 10, 12, 14, 16, 18. Di ba? So, consists of integers less than 20 divisible by 2. So, meron tayong 2, 4, 6, 8, 10, 12, 14, 16, 18. So, ano yung truth value natin for every x? So, P2 false, P4 false. So, F lahat. Okay, so tingnan natin. So, hintayin natin yung iba. So, false. False po lahat. So, tingnan natin. If false nga ba lahat? So, 4 squared is 16. So, false. So, 6 plus 6 greater than 6 squared is equal to 6 times 6, 36. So, is equal to false. So, nakikita natin doon sa pattern, lahat magiging false kasi mas mataas kapag in-squared natin kaysa i-add lang yung value ng x. So, magiging false. So, actually, pag nakuha natin, may nakita tayong isang false, alam na natin, yung truth value ng statement natin is equal to false. Kasi, ang dun sa universal quantification na there is false for an x, na meron lang mag-isang false, false na lahat yung, o false, ipoprovide mo. Okay? So, So, very good. Okay, question. 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 Violent reaction. May tanong?
Wala na po, sir.
Wala
Okay
po,
na.
Wala
sir.
na po, sir.
About
Wala
yung
na po,
iba,
sir.
baka meron pa kayong part na nalilito kayo. Wala na? Okay, so magpo-post na lang ako ng activity. So, hindi ko lang alam na ngayon ko may post dahil magbabawi lang ako ng tulog. So, mukhang hindi ko magagawa ngayon. So, kung maayos ko bukas, after duty, post ko na lang sa Google Classroom. Nano-notify naman kayo, malalaman nyo naman kung may activity. Pag late ko naman na i-post, ni-extend ko naman yung pasahan yung deadline. Okay? So, pakitype na lang muna yung present sa chat box.